Getting started. Okay, nice. Hi everyone, and hope you're as excited as we are for the camp. This is the first day, first class, and no one better to start it off than Malay. Malay is a good friend, and he's going to talk about functional equations. So that'll be fun. And okay, some words about Malay. He was doing a lot of math ali in his high school. He's currently a first year undergrad student at the Chennai Mathematical Institute. And he recently was ranked 3 in the very prestigious all over the world and top in India for the very prestigious Simon SMMC. It's a contest for math contest for undergrad people, and he was, I think, also the youngest tutor at MBL, Math Beyond Limits camp, just at 18. So also he's very good at geometry. He's going to take a geo class tomorrow, so that should be fun. Thank you so much, Malay, and over to you.
Yeah, thank you very much for the introduction. So, hello everyone, I'm Malay Mahajan. Today I'll be taking FEs. So, before I begin, just a couple of general instructions. As you will see in some time, my handwriting is absolutely terrible. If you can't read something, just feel free to stop and interrupt me. If you have any doubt at any point, just unmute and ask. And please prefer unmuting and asking rather than checking chat. Checking chat and so on and responding is a bit hard. So yeah, if you have any doubt, just feel free to ask. There's no hesitation. And yes, so let's begin. I hope you can see my OneNote. Ignore that. So wait. Yeah, so as promised, I'll be doing functional equations. So as I said before, the focus might be a bit more on R plus FEs. So generally, or at least conventionally, the FEs we used to have, say like 20 years ago, not 20, maybe 10. Generally, most of them would be from reals to reals, but recently there has been more of the style of R plus FEs. When I say R plus FEs, it means FEs from positive reals to themselves. And so what is a big difference? And the point is you don't have zero. Generally in RFEs, you put zero and a lot of terms just cancel. A lot of terms just go to zero. You don't have that anymore. You can't even put, yeah, basically you can't put zero anywhere. So that's seen as a disadvantage, but there are a lot of other cool tricks, such as one of the best things here is you can do index and bounding. Uh, for example, like to demonstrate like the problem when we literally have this domain, it literally says every output is going to be positive. So for any x, f of x is going to be bigger than zero. So we already have this bound, but we don't have that in real FEs. So just to get off started. So at the start, I'll just be writing some tricks. Please don't treat this as a trick list for all FE problems. These are just some of the tricks I have in mind. I wouldn't be even doing all of them, but just so that you are aware of these tricks. So to start some general FE tricks, I hope all of you have seen what injectivity, surjectivity is. You generally try to check if we try to prove the function is injective or surjective at the start. Then there is this trick called forced cancellation. It's fine if you haven't seen this before. Cancellation was the spelling 80. Yeah. So basically in this trick, you forcefully try to equate two things. So if you try to forcefully equate two things, those terms will just cancel and you will have less terms and maybe you'll get some nice things. I'll be talking about this. And there is one more which I don't see in many places is adding a variable trick. Unfortunately, I won't be doing this trick today. I don't think I'll get the time. But you can check Pang Cheng Wu's book. He has a nice chapter on this. And now some exclusive tricks for R plus FEs. So the first and foremost, as I said before, is uniques and bounding. When I say uniques, we won't be doing AMGM, Cauchy-Schwarz, and so on. We would just be doing fx greater equal x and so on. So then there is something called the APA mode trick, and well, I'll have to give an example. I'll have to do the trick. And there are two more important, which unfortunately I won't be doing in today's class. This generally works for R plus FEs. Is you prove increasing plus linear over Q implies linear over R. This works for real to real FEs, but in most cases, at least in all examples I've seen, you do this only over positive reals because it's not easy to prove increasing in all problems. Generally, if you have R plus FEs, it's a bit easy to prove monotonicity. So what this says is, suppose you have a function f such that you have shown it's increasing, and you know that fq is aq plus b for all q in q, where a, b are fixed constants. Then this plus increasing, you can try this as an exercise later to prove that you can actually infer for all x in R. So yeah, and so generally how you do this, so how do you go to rationals? You do it for one. Like suppose you take f1, then you suppose from 1 you can go to 2, then you go to 2, then you go to 3, and so on. So you can get to all rationals, all positive integers. And once you have for positive integers, say somehow you can go to m by n. If you know f of m and f of n, then you basically get it all rationals. So that is how we generally approach it. And the last is Cauchy. This is special to R plus. Cauchy implies linear. So as you might know, Cauchy just means a function that satisfies f, say if it's from R to R for now. Suppose it satisfies this for all xy. And the question is, are the only solutions linear? And the answer is unfortunately no. There are some really, really bad solutions, and it's very hard to deal with them. And suppose you infer this in a R to R problem, then you are not done. But if the problem is R plus to R plus, then you're actually done, because when you remember when I said it's from R plus to R plus, you know that f of x is greater than 0 for all x. So these two conditions imply it's linear, because because if you have a bad solution, then there are some conditions on it, that is it's unbounded in every interval and so on. But the point is there's a bound, and I don't want you to prove this. I think you can assume this even like if you want to read more, then just Google and read about pathological solutions to Cauchy's functional equation. So as I said before, this is a bit of general trick. This and this I won't be doing in today's class. But I encourage you to, try to read about them. And I'll be trying to I'll mainly do about these three things. I mean, it's not a trick, you just try to, like, don't try it as a trick and, you just see an FU, I'm going to do this, but these should be the ideas that in your mind. So, any doubts so far? Okay, I assume no doubts. So, yeah.
Is the Cauchy thing true because f of x plus y equal f of x plus f of y is greater than f of x because it's increasing, and from the previous, does that proof work? Since we know it's increasing and we can prove that it is linear for rationals, so done.
Okay, great. Yeah, that would work too. That would work too. Great. Nice. So yes, okay. So I assume no other doubts. Let's get started. I'll pose the first problem. So just give me a second. Oh yeah, and one more general instruction: if you get if you get some progress, then just unmute and let me know. Oh yeah, and in general for FEs, and this is something I like to do always, try to see what solutions work. Like for example, if x does not work and the solution is 1 by x, it's pointless to trying to prove it's x. So check all solutions that work. Or I mean, fx equals x generally works. Always check if there are other linear solutions. So here I can confirm, I think the only solution is fx equals x. If someone has seen this problem, I'll give another buffer problem. Uh, uh, just give me a minute. Okay, so any ideas?
I think there's some progress put in the chat.
Press 1 for cancelling.
What do you want to cancel?
You have f of y and f of y. Like in the
Can
LHS,
yeah.
yeah, like what I'm telling is that if you put x equals 1, you'll get f of 1 plus f of y, f of 1 plus f of y times f of y equals to f of y times 1 plus f of y. So f of y cancels because it's not 0. So you get f of 1 plus f of y equals 1 plus f of y.
Yeah. So in general, when I write this, it means the assertion x and y. So I'll be using this notation throughout the class. So as you said, you put x equals 1 first, then you get f of 1 plus fy times f of y is f of y plus f of y squared. So you can cancel out an f of y and you get 1 plus f of y.
So I guess f of x equals x.
Yes, so because of this, you can check that no other linear function should work. And you must have fx equals x, that's the only solution. And you can check constants don't work either. So this is all going okay, that's good. Okay, so I'll try to, since this is the first problem, I'll try to give some more ideas. The point is we want to forcefully, okay, I forgot to do this. Before we begin, let's look at this problem. I won't be solving it because it will be one of your homework problems. So suppose you have an FE from R plus to R plus, f of 2x minus fx is x, and f of pi is 22 by 7. Does there exist an f such that this? So what are the first things that come to your mind looking at the problem? Like, don't try it, but does the problem itself have a condition?
Projective.
Okay, yes, it's
Automatically,
subjective.
we have subjectivity.
Yeah, you have selected, that's good. But one more thing is, well, in this case, in this problem, it's like direct. The point is, because it's f of something, this has to be positive. So you already have a bound. 2x is going to be bigger than fx. Generally, in problems, you don't get it bound directly, but this is something that happens. And yes, now, so yes, so someone put it in chat. That's it. I won't be discussing this more. This will go on your homework. So here it's almost an obvious example of this. In problems, it's not so obvious.
I got
So,
f of y greater than equal to y.
oh, you got f of y greater equal y. How did you get that?
Greater to y.
Sorry?
If we put x equals to y minus f of y, we get f of xy equals to 0, which is a contradiction.
Why do I know y minus f of y just satisfies stuff? What if it's negative?
Yeah.
Then like xy is
Yeah, I'll
fine.
explain. Yeah, I'll
That
explain. I'll explain. So you have f of x plus f of y times f of y. I'm writing the bracket so that it's just a bit easier. I'm writing the same equation plus f of y squared. So try to force things to equal. So earlier we thought of putting x equals 1 here so that this thing becomes same. So what if we try to make this thing as y? If we try to make if we make x plus fy as y, this term on the left hand side would become f of y squared. We would get is f of xy plus f of y squared. And why do we want to put this y? The reason is we want to make this side same as this thing. So if this becomes y, then these two sides will cancel and you get f of xy is 0. But that's not possible because the function is from positive reals to positive reals. So the point is you cannot do this substitution. So I cannot do this. So in other words, I'll write it differently. Assume possible. Basically, what does this say is this is same as saying x is y minus fy. So assume possible y is bigger than fy for some y. Then consider the assertion y minus fy comma y. As in put the value of x as y minus fy where y is as before. By what I explained before, this side you will get f of y squared equals f of xy plus f of y squared. Observe this assertion is valid because I have assumed this is a positive quantity and we will get a contradiction. So what is the issue? Our assumption is wrong and hence fy greater equal y for all y. Is this clear to everybody? So yes, this is what I meant by the problem itself has a condition. In last, it was fairly direct, 2x should be bigger than x. Here, it's not that direct, but the point is you cannot make these two sides equal. So you have a condition. So is this clear to everybody?
Also, one more question I have is that the thing, yeah, here you have f of 1 plus fy equals 1 plus fy. So we can directly write f of x equals x without doing anything.
No, 1 plus fy need not vary over all positive reals. For example, how do you know 1 plus, 1 plus fy, for example, doesn't take the value half?
Yeah, right. Okay, so we need to prove f of x equals
I'll
x.
just suppose the image of f, like image of f, suppose the image of f is suppose possible, it's just the integers, as in a positive integer. Suppose f only takes positive positive integers, then what this equation says is this. The point is f of y is restricted. You cannot vary fy over all reals. You can vary it over the image, but the image need not be reals, right? Yeah. So I hope this is clear to everybody. This is probably like one of the most important things. Key, you get an inequality by this, and now you try to do stuff. So yes, I'll write the equation once more. F of what is it? X plus fy times f of y is fxy plus f of y squared. Do we equate now? Yes, that's one idea. You somehow by some other argument prove that fy is at max y for all y, then we would be done.
Using f of y is greater than or equal to y, we can substitute that in the 1 plus f of y equation. So we get 1 plus f of y is greater than or equal to f of 1 plus y.
You will get this is at least 1 plus fy. That unfortunately doesn't give any information because it's
No,
already
no.
equal.
F of 1, like f of y is greater than or equal to y. So like uh, f of 1 plus y is, yeah.
Yeah, but the issue, but yeah, sure, that's correct. But the point is, it does not give you information because this equality is strictly stronger. Yes. Okay. Adit, how did you get that?
So first I looked at it like, so we have the RHS, which is f of xy plus f of y whole square.
Mm-hmm.
And this is equal to the LHS. And using f of x greater than or equal to x, I have like LHS is greater than or equal to x plus f of y times f of y, and then the f of y just cancels out nicely.
Perfect. So the point is you have a very good bound. Fi is at least y. And if you look at this equation, this term is bad in the sense that it's too much, there's too much stuff in it. So if we somehow get rid of it, that's good. And so what do? We use the bound. This thing is at least x plus fy times fy. Where I have used the bound x plus fy is at max f of this by this thing. And one more detail, the point is we are working over positive reals. So this equation is true. This equation is true. Basically, I have written this and then I multiplied both sides by fy. The point is this is true because we're working over positive reals. Okay, I'll write it again what I'm saying. F of x plus fy at least x plus fy. And now what I do, I multiply both sides by fy. The point is, as you know, this won't be true if f is from reals to reals. If fy is negative, the inequality sign would in fact switch. So keep that in mind. Don't this in most cases won't work over reals. And this is where the positive real kicks in because you can multiply and so on. So just give me a second. So let's see. So this side we have x fy plus f of y the whole square is going to be at max. On this side we have f of xy plus f of y squared. And these two is just nicely cancel. So we get x fy is at max is f of xy. So any ideas to make this nicer? Okay, someone pointed in chat. So divide both sides by xy. And this thing becomes f of y by y is at least f of xy by xy for all xy. And this is
Oh, and
great.
then we're done. Because
Yes,
then
it's
equality
great
has to
because
hold.
yes, the point is you can take anything. Like f of xy is same as saying f of y over y less equal f of z over z for all y comma z. And now switch y and z, you get f of y over y must be equal to f of z over z for all y z, and hence give it a constant c, you get fx is cx. And then check put in the equation and check, you should get c equals 1. So is it clear to everyone?
Yes, sir.
So here what we,
Yes, sir.
yeah, so here what we did is we put it and then we got an equality, and that just works because you have some function in one argument is at max some same function in another argument, which are two completely random things, so they have to be equal by just switching. So I hope this is clear to everybody. Okay,
Yes.
I do. Cool. So I assume no doubts, and let's move on to the next problem. Yeah, and this yeah, this might be new problem for everyone. If still someone has seen this, then I'll give a buffer problem. No, wait. Sorry. Yeah. And I won't be writing for all xy in every problem, but this is true for all x. Okay, so so people are trying to find the solutions. If you put constant, observe the only constant function that can work is the function 1. Yes, and there's an observation. Would you like to unmute and tell?
F of x equals to 1 by x works.
Yeah. So check in this problem, fx equals x does not work, and neither does any linear, non-linear other than 1. Any ax plus b won't work. But here, if you check, so if linear doesn't work, check maybe 1 by, if x doesn't work, check 1 by x, and it actually works. So it's useful to have this checked before you start running the problem. Okay, that's a good idea. So, would you like to speak up about the one about forcing two things to be equal? Okay, it's fine. So the idea is you try to, as pointed out in chat, you try to force. So again, this is a weird term. There's too much terms in this. So you try to force this thing to be equal to this. So I want to equate these two things. And when can I equate this? This is same as saying y is 1 minus fx over x minus 1. Yes, I think I can do arithmetic. Yes. So if I'm able to put y as this thing, okay. Now consider p of x comma y as this. Then what will I get? I'll get fx is
I
1.
think it would be
I think it
fx
should be
minus
fx minus.
Sorry?
I think it should be fx minus 1.
No, I think this is correct. X minus 1. Oh, wait, what?
Yeah, y is like you've written
My
minus
bad,
y.
my
This
bad.
is yeah.
Oh, my bad. Thank you, thank you. I did 2 problems yesterday of the exact same thing, and I misremembered for my bad. Yeah. Yes, so if you do this, then you get this. And is this an issue? Or
We
is it
might have
fine?
like domain issues.
It shows that
Yes, exactly. Yeah, as pointed out in chat. Yeah, as pointed out in chat, the point is I'm assuming this is in positive reals, but if fx is 1, then y is not a positive real number because y just happens to be 0. So so is the contradiction clear to everyone? I was not right. 0 factorial, I was right. This. Yeah. So the point is y cannot be a positive real number, and hence you get fx minus 1 or x minus 1 is negative. So what it says is f of less than 1 is
Negative or
equal 1.
less than or equal to 0, not just less than 0.
Sorry, yeah. So thanks for finding. So and f of a number bigger than 1 is at maximum. So is this clear to everybody? So but this, it's a bad notation, don't write it like this, but a number less than 1, it outputs to a number at least 1, and a number bigger than 1 outputs to a number at max 1. So is this clear to everyone?
Yeah, it makes sense.
Yeah.
Oh, also 1 plus xy is just more than 1. So maybe we can do some stuff with that.
Okay. So observe the right hand side is always going to be more than 1. So I know ki f of 1 plus xy is going to be always at max 1. And then succeed by doing Injectivity at 1. Okay. Yeah, I'll come to that. So you have f of x plus, no, it was that, y plus fx. Y plus fx, we know is always going to be at max 1. That's something good. And yeah, as pointed out in chat, would you like to unmute and tell the idea? Okay, it's fine. So what do we so basically it's only yeah. So you try to make these two things equal. Yes. So here now you try to make these two things equal, this and this. So when can I do that? I want x equals 1 plus xy, which is same as saying y equals, yeah, which is same as
X
saying,
minus
okay,
1 by
just
x, I think.
so y equals 1 minus 1 by x. And when is this valid? I'm assuming x is bigger than 1. So I'm assuming x is bigger than 1, and I put this assertion, which I can put. So when I do p of x comma 1 minus 1 by x, I get f of x times f of 1 minus 1 by x plus fx is equal to f of the other side. But the point is, because of our construction, 1 plus xy is equal to x, so these just cancel and you get 1. And well, this is great because if we had injectivity, then we would infer that this is a constant. Sorry. If we had injectivity, then suppose f there exists unique c such that f of c is 1. We would get 1 minus 1 by x plus fx is c for all x, and it's fine. After this, we can finish. So that's great. So now our goal has reduced to proving injectivity. So is this clear to everyone? We won't be done for all x bigger than 1, but it's fine. We know it for all bigger than 1, then we can just put and would be done. So is it clear to everyone?
Sorry, how are we done after we prove injectivity?
Okay, we are not done, but the point is, you know that where's my cursor? Yeah, sorry. So we know that for all x bigger than 1, fx will be 1 by x plus a constant, call it k. Okay?
No, like how do we get
Then
that?
if we have injectivity, then there would, because of this equation and injectivity, there would exist a unique C so that FC is 1. Look at this. Then this thing must be equal to C, right? Because it outputs to 1.
Okay.
So we would just get f of x is 1 by x plus k.
Yeah, got it. Thanks.
Yeah, and now just try to put, then I think if you can force k to be 0, and then you can even get it for smaller values. Okay, so our tool has now reduced to showing injectivity.
Small thing.
Yeah.
So if we're trying to prove injectivity, we're gonna have to somewhere at least in the proof assume that f is non-constant. So I presume the proof would look something like assume fx equals f of y and then prove that f is constant.
Yeah, okay. I forgot to say this, but it will come in the solution. So the point is, suppose it's not injective, then you prove it's constant. Generally, at the start, you just assume f is not constant so that you don't have to keep worrying about it. So yeah, that's not complicated. So now, yes. So is everybody clear? Our goal is to prove. Suppose f not injective, then prove f is 1. Yes, I have the chat. Maybe prove f equals every, then fc is 1, 2. Okay, suppose fa is fb. I don't think it's. What is c there? How?
So not injective implies constant or 1 comma infinity because then we just look at the LHS of both of the equations and we see that there's no free x term in a sense. So we can just simply put x equals to a, x equals to p, assuming fa equals fb, and then the RHS basically y can vary over pretty much everything. So we should be done, I think.
Unfortunately, not. We are not directly done. So suppose you have this, then you as you said, you put x is, I think x, right? Yeah, you put x as a and you put x as b. What you will get is fa times f of y plus fa is f of 1 plus ay. And here you get this f of 1 plus by. Because these two are equal, you get f of 1 plus ay is f of 1 plus by. But this doesn't force.
Right.
Yeah. And so
Can
now what you do is, yeah. Okay, so now what you do is you just, it's just a small thing. You set C as b by a, and you can, without loss of generality, assume C is bigger than 1. Otherwise, just take a by b. And from this equation, what you now write it as 1 f of 1 plus y is f of 1 plus c by. So is this clear to everyone so far? So we have got this condition which is quite strong. It says suppose f of a is f of b, then it says f of 1 plus ay is f of 1 plus by for all y. And we just wrote it differently. So yeah. Is everybody on board so far? And in fact, I'll be talking about this thing later. It's a bit similar to what we do in the APM trick. It's not exactly this, but the style is a bit same. But we won't be doing that trick in this problem.
Okay, one more thing this gives us is that like there's gonna be infinitely many chains of values for f where f is equal in a sense, and each of those chains is infinitely many long. So intuitively we'd expect that this is too much information for the condition to handle, and we'd expect that there should be some sort of contradiction somewhere.
Yeah, so what do you mean by chain? Can you tell it explicitly?
Like there exists like infinitely many infinite sets, such that for each set the value f of that set is like just a singleton set.
Yeah, okay, so in general that might happen, but here the numbers are nice. Can you tell? I mean, like, so what is the set here, for example?
Like we can have here 1 plus y, 1 plus cy, 1 plus c square y, and so on.
Yeah. Yes. So you don't restrict it to just this, and by exactly this thing, you can keep doing it more. So you can have f of 1 plus y is f of 1 plus cy. Do the same thing on y. You get f of 1 plus c squared y. Y is the last thing true because just take cy as y and you multiply it by c. Is f of 1 plus c cubed y and so on. And this is the reason I decided to go to C. The point is if I did not go to C, then it would look like f of 1 plus I don't know b squared by ay and so on, and this just looks weird. So it's easier to have this. So now we have this thing f of 1 plus y is f of 1 plus c to the power n y for all y and for any n in positive integers. So is this clear to everyone? And recollect c is bigger than 1.
So basically, another thing this gives us is that every value in the image of f appears for arbitrarily large values in a sense. If that
Okay,
helps
that's a
us
good
get
idea.
that point.
Yes, we will be using that later. Okay, so we have this one thing, which is this. Okay, any ideas? Any other ideas? Okay, I think I'll move on. We have this one thing, f of something less than 1 is at least
I think
f1
I
and
have
the
some
other way around.
idea.
Sorry?
We can set in the original equation y to f of c such that f of c is 1 in the
Okay.
original equation. Y
Yes.
to f of c.
Uh, let c such that fc is 1, note it exists because f of something is 1 we have shown. You're saying put y as c?
Um, y as f of c.
So f of c is just 1.
Yeah.
So okay, if you put that, you get f of x times f of 1 plus fx is f of 1 plus x. But that doesn't really give too much information, right?
Oh, yeah. Yeah.
Yeah. But okay, that's a good attempt. So, okay, so we were trying this at some point. This idea unfortunately doesn't work, but so what was our goal? Our goal was to, as we saw in the previous problem, one of the terms which is bad, you just want to delete it. But you want to also have some bound on it because you don't want to have extremely loose bounds. So, which is the bad term in this expression? By in the expression, I mean the given equation, which is the bad term.
Y plus f.
Yes, so this term is really bad. We don't want to work with it. Other terms are easier to work with. X and 1 by x. Yeah, this side you'll get 2 f of x times f of 1 by x plus fx is f2, but that's again also a bit hard to work with. Like there might be solutions that use it, but at least not mine. So we want to somehow get a bound on this. So we will do the following thing. So suppose x is bigger than 1. So what do we want to prove? Remember, we want to prove f is constant 1. So not suppose, let f be 1, and suppose possible. Okay, we do know that fx is at max 1. This is fine for everyone, right? And I want to show it's equal to 1. Suppose it's not. Fx is strictly less than 1. So what do? I make sure I want to get a bound on this term, f of x plus this. How do I get a bound on this?
It it should be like at most f of 1 plus xy. Just naively using the bound that we have.
Okay, yeah, okay, that's a bound because you know fx is less than 1, you use it on this. But the point is, we use that bound, this term disappears. But this term remains. We don't want that. We want this term to go. Do you get the point? As in, I want to eliminate the term f of y plus fy, y plus fx.
You can put,
I see.
you can put this is f of y plus value less than, this is the value less than y plus 1, f of y plus 1.
Yeah, you know f of y plus fx will be the value, but you don't know how to compare f of two numbers.
I think
Remember, this
y
is the...
to 1 minus
Go
f
ahead.
of x. Y2.
Great. Yes. So remember, the only bound we have is this. In last problem, we had a bound fx is at least x, I think. Here we don't have anything. So the point is, you make sure y plus fx is less than 1. Suppose, say we ensure y plus fx is less than 1. I can ensure this because fx is less than 1. So I can still add. So think of fx as, 0.9999. And the point is, you can still add some y so that the value still remains less than 1. I hope everybody is fine with it. In particular, y should belong to the interval. Let y belong to the interval 1 to 1 minus fx. And this is a positive quantity. Okay, so say I ensure y plus fx is less than 1, then I know f of y plus fx is going to be at max 1, is at least 1. So what do I know? I know that f of x is going to be at max f of 1 plus xy. Is that clear for everyone? No, wait, I think the other way around.
Yeah, it should be greater, I think.
Yeah, it's the other way around. Don't mind.
No, it's less than or equal.
Wait, arithmetic is hard. This thing is at least 1. So this thing is at least fx. Yeah, it's the other way. And so a bit of motivation why we are doing this. So remember, it's like, so I'm kind of here, I'm kind of assuming. So far I have not used the fact that it's not injective. I'm just trying to prove fx not 1. I'm just trying to prove fx equals 1. So this thing is something less than 1. And the point is, I want to make this even smaller. So that should be our goal. But we cannot do that always because we already have a constraint on y. But remember,
can
we are
just
trying to
multiply
prove.
by c. Why can't we just put
Yes.
y to
Yeah,
the
we
c
can
is a
make
very
like
large
x
value?
huge. because of
No.
that.
No, x is fixed. X
Yeah,
is
X is
fixed.
fixed.
Remember,
But-
x I have fixed it. Yeah.
But for y, we can first is we have a
Alright.
very range. Like we have a range for y. We have 0 to some tiny number, but
Yes,
0 to
yes.
some tiny number into some huge number is 0 to some huge number.
Yes,
So-
got it. Yes, perfect. Yes. So remember, here till so far, as I said, we have not used the fact that we are trying to prove injective. So remember, when we were trying to prove injective, we had got this very important equation. So f of 1 plus y is f of 1 plus e to the power n y for any y, for any y and n. So I know that this is also equal to f of 1 plus x y times c to the power n, right? And the point is, I can take any n that I want, and this thing I can take absolutely anything. So I'll formalize. Call 1 plus fx is epsilon. Okay, let 1 minus fx. Don't worry, I won't be doing analysis. If some of you just think is epsilon or I'm going to do analysis, don't worry, which is positive. So for y in 0 to epsilon, remember epsilon is a positive number. Think of it as half. Just if you want to think it simply, just think of it as half. So for y in this range, I have fx is at max f of 1 plus xy. So as I vary y in this, what does this quantity vary? It varies over, as I vary this, it goes from 1 to 1 plus epsilon x. This inner quantity. Right? As I vary y from 0 to epsilon, 1 plus xy simply varies from 1 to 1 plus epsilon x. So I get f of x less equal f of y. Let me not use y, f of z. For all z belong to 1 comma 1 plus epsilon x. Fine. Now what do? I now use the bound of I use one more in here. I can say f of x at max f of 1 plus xy times c. Now, as I vary y, remember y is always going to vary over 0 to epsilon. That is fixed. Why is y varying over this? Remember, we have this equation. So I want y plus fx at less than 1. So y is constrained to 0 to epsilon, and I can take all values. So as I vary this quantity 1 plus xyc varies over 1 to 1 plus epsilon x times c. Great. The earlier, so okay, I'll write it again with the same color. Fx is at max f of z. For all z belong to 1 comma 1 plus epsilon x times c. Now what do? I do it with c squared. Okay, this time I'll just do it with c to the power n. And as I vary this quantity varies over 1 comma 1 plus epsilon x c to the power n. So for all n, fx less equal fz, where z belongs to 1 comma 1 plus epsilon x c to the power n. So what's the point? I have fixed an x and I should write. So this, do you understand? As I take n arbitrarily large, I can ensure this takes any value because this is why epsilon is a positive constant, x is a positive constant, and remember c is bigger than 1. So c to the power n goes to infinity. It just takes arbitrarily large values. You can make it bigger than any number. So you can make epsilon x c to the power n bigger than any number. So do you see why this is true? For all z bigger than 1.
Sir, can't we just have f of z equals to 1, in which case this won't be true? I mean the
Yes,
opposite.
we
We
can-
can do the opposite for the opposite case, right?
Yes, I'll come to that. But is this clear to everyone? What we did? The point is, I have this interval 1 to 1 plus. If you want, forget the epsilon and x. They don't matter. They just are there for the constant scaling. You have 1 to 1 plus c, then 1 to 1 plus c squared, 1 to 1 plus c cubed, and so on. And the point is c to the power n goes as large as you want. So given any z, it contains in some interval, and hence you just have this. So is this clear to everyone?
Yeah, it's clear.
Yes.
Great. Yes, and yes, as Adit points out, the importance of assuming C bigger than 1. I don't know if I talked there, but if C is less than 1, just take A by B, you get it's bigger than 1. And the whole reason this is bad is if C was equal to 1, if C was equal to 1, then C to the power n always remains 1. You don't get any information. So, and yeah, and assume, and I've showed key. So, okay, so let's see where I started with. I started with an x bigger than 1, and this is what I assumed. This is where I started, and this is my assumption, fx less than 1. And this is what I showed. So the following statement is true. For all x bigger than 1, either fx is 1 or fx less equal fz for all z bigger than 1. Is this clear to everyone?
So now we kind of have a pointwise in a sense, where we're dealing with some 1 and some other constant C less than 1.
Yes. So over reals bigger than 1, this is the next step. F takes at most 2 values. Like the point is, suppose f of x1 is y1 and f of x2 is y2, where y1 y2 are not equal to 1, then because of this condition, I would have y1 less equal y2 and y2 less equal y1, which would force equal. So there is at max one value other than 1. Is this clear to everyone?
Yes.
So for all x, and as you said, we now have a pointwise trap. For all x bigger than 1, fx is 1 or fx is a constant, I'll just call it r. And remember, r is going to be less than 1. Okay, so just to check if people are alive, why is r less than 1?
Can I?
Why is r less than 1?
Because we assumed it in the starting.
X greater than 1, so f of x is smaller than 1.
Yes, okay, good. Yeah, or you can just do this. Okay, fine. So, and this is great. So, and we are basically done. We have shown that just over positive over reals bigger than 1, it just takes 2 of these values. And so what was one of the most important steps here? One of the most important steps here was this thing. The point is, we don't stop at C, you just add more intervals and then you can take any interval, and that is what we did later. So I think Adit had said ki the chain you have takes arbitrarily large values, and at that point I said it will be useful later. So yes, this is where we used it. So now we can just solve it directly. Like you can show ki fx equals r is not possible. Yeah, so suppose fx equals r. I mean, this is not the interesting part. I'll just do it in one step and then I leave. You get r times f of y plus r is f of 1 plus ry. Right? Then take y bigger than 1. This expression belongs to 1 or r. This expression belongs to 1 or r. But that's just not possible because I have sorry, that's possible, and I get that f is 1. You just get y check 1. So show it for and then you put in the equation again, you can get it for small values. And I'll leave this after this. But what was the main part of the element? It's clear to everyone?
Yes, very cool.
The third,
And
you didn't cover the other case, right? Like what even if we figure out that for x greater than 1 it is 1 by x, like you can show that, how do we prove it for x more than 1 that is also 1 by x? How do we continue it to x smaller than 1?
Now we can just
oh,
take y to be large, right?
yeah, I think in the equation just put large. The point is if you know values more than one, if you know inputs of more than one, just take large. You know all the terms except say one thing. Yeah, just take y large.
Basically the RHS is 1, and you can make y plus f of x to be more than 1, so you're done.
Like take y large. This term is bigger than 1, so you know the output. Because y is large, just take y bigger than 1. Okay, you don't even need that. Y bigger than 1. Because this is bigger than 1, you know it. Because this is bigger than 1, you know it.
But
So
you
you
don't
infer
know it.
it.
F of x you don't know. You don't know y plus f of x because you don't know f of x.
No, I've
But
I've
f
shown
of
ki
x is fixed.
Uh,
For some fixed x, f of x is fixed.
oh, so you do it like that, right? Please.
Yeah.
So you could k by 1 plus f of
I
k.
mean that's fine. That should be like you don't have to figure it right now. That's not the important part. So I'll just revise over the proof once more. So uh, going by the earlier problem's idea, we tried to wait for me. Yes. So we tried to do some bounding, and we realized f of n. We realized this bound. Again, we tried to force two things to be equal, or they can't be equal. So we got an inequality. Then we realized if we have injectivity, then we would be done because of this thing. You just get f of x is 1 by x. So we now assume it's not injective, and our goal is to prove it's 1. So say f of a is f of b, then we got this very important expression. This will be the theme for the next problem. You got f of 1 plus ay is f of 1 plus by for all y. And hence using this, you get f of 1 plus y is f of 1 plus cy, where c is a by b. And the point is you don't stop at c, you just go into higher powers and you get this. And what's the advantage of this? C to the power n goes large, so you have more control over large terms. And yes, then we went to this. So you let an x, you fix an x bigger than 1, and suppose fx is less than 1. Then you take y in some small range so that y plus fx is less than 1. And once you do this, the point is I know this quantity is less than 1. So this quantity is greater or equal 1 because of our initial bound. So using that, you get f of y is at max f of 1 plus xy for all y in this range. But remember, f of 1 plus something, I can just add a c to the power n later. So I keep adding a c to the power n, and I can take any number as large as I want. So I just get f of x less equal fz for all z, which are bigger than 1. So fx takes only two values. You can just check one or the other constant, and then it's fine. Then you have basically determined it. So I hope it's clear to everyone. And yeah, I might have gone over some parts a bit quickly. It's fine. You should try to figure it out later on your own so that you understand the problem and the steps. Okay, so just give me a minute. I'll post the next problem. So if someone has seen this, then I've already given a buffer problem.
Also, over r plus, like it seems like it should be. I don't know why, but for some reason it seems easier that you should be able to do some sort of limit slash continuity type argument. Like, is that a thing or is that not a thing?
It is a thing, but that's a complete separate, not class, like maybe a series of classes, like doing doing analysis as in proving function is continuous at 0 or stuff and so on. And that's a separate thing. And that theory is also really cool. Maybe I'll do it later.
P of XX seems good to start from.
Sorry, just give me. Can you repeat?
Yeah, sure. P of X and X seems quite good to start.
Yes, because two terms cancel. You get f of x plus fx is f of x squared. Okay, so what are the guesses for the answer?
All constant answers work.
Yes, all constant work, and like linears don't work. One by linear also don't work, and because you just put x equals 1, you get f of 1 plus fy is f of 1, and this is just too much. You can't have. And based on this thing, you really expect it to have only constant solutions.
F of A equal to F of B implies F of AX equal to F of BX.
Where P is?
Huh? No, if we have A and B mapping to the same thing, then we can put Y equal to A and Y equal to B.
Okay, good. Yeah, just give me a second. I'll complete. X is this. Yeah. So suppose FA equals FB. And you'd put Y as this, right?
Yeah.
You get FA f of X plus FA equals f of A f of AX, f of B f of X plus FB is FB f of BX. And the point is these two terms are same, these two terms are same, these two terms are same. So you get f of AX equals f of BX.
I think there's some minor issue like RHS, it should be FX into FXA, FX into F instead of FA into FAX.
Yes. Thanks for pointing here. Yes, so the point is we assumed FA is FB and we got this f of AX is f of BX, but the point is we asked it only for x equals 1 and we have got it for all x.
I
So
think
now we
that's
can like do the chaining thing again is one thing.
XY equals to. Oh,
Yeah, go ahead.
I think I have got if XY equals to X plus f of Y for Y not equal to 1, then some terms cancel out.
Can you repeat?
XY equals to X plus f of Y.
Okay, you're trying to set this. So x must be fy over y minus 1. If you set this, then you get fx equals fy. So you get f of x is f of fy over y minus 1 is f of y. Yeah.
For Y greater than 1.
Yeah, for y greater than 1. Okay, so I'll come to this point once more. Sure, these are good ideas, and I think my solution was not the one I'll be presenting, and I think I did use this. So you can definitely complete, but this is not what I'll be doing. I have to. So basically, this problem is about APM metric, and This is a very small example of it. So we got this for all x. So set c is b by a, and we get f of x is f of cx. And as I think Adit pointed out, you can do c to the power n x. So what do you do in this is, in the original problem, we replace every x by cx. The point is, most of the terms should not change because we have this. I'll give you
Can
some
you
time to think about it.
can you repeat the substitution you said?
Yes. So in the given equation, replace x by cx or replace y by cy. The point is, most of the terms won't change. For example, suppose I replace y by cy. Here I'll get f of cy times f of x plus f of cy equals fx f of cxy. Fine. But I know f of cy is same as f of y. This is same as f of y. And this is also same as f of xy. The point is, I can just cancel out a c by the last thing we got. And okay, we got the exact same equation. This gives no information. So what do we do? Instead of changing y to cy, we do x to, like, consider p of cx comma y. You get f of cx, f of cx plus fy equals f of y, f of cxy. But remember, I can cancel out a c, so I get f of x, f of cx plus fy equals f of y plus f of times f of xy. Remember, these three terms are same as those in the given equation. So I can infer f of x plus
First
fy.
term was y.
Isn't the
Sorry?
first term like f of y? The first term.
Sorry. Yeah. Nothing changes there as well. So you get this. And okay, so this is one more step. Here we only had f of x equals f of cx. Instead of, okay, here we cannot put fy is 0. But the point is, if you think of fy as 0, this is what we had earlier. But now we have added one more thing in the constraint, which is you can put any f of y there.
So then this quantity should also be equal to like f of x plus f of y over c, I think.
Yeah. So instead of doing by c, I'll just multiply this by c. So remember, this is also equal to f of cx plus cfy. So
Ratio
okay, if you
cx
want
plus f of y by cx plus cf of y is another c dash. And we can just vary x to get like a range of c dashes. The range will be from 1 to very small 1 to c. And since 1 to c, matlab ki it will be this bracket, open bracket from 1 to c.
no, wait. Can you repeat what you're doing?
What I did was I created a c dash equal to cx plus f of y by x plus f of y. Cx plus f of y by cx plus c f of y. Okay.
Okay.
I varied x from slightly greater than 0 to very, 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 very large. Okay, and then I get a range of f of c dash is equal to 1 close bracket 1 to close bracket c.
So you're considering the ratio.
Yeah.
Okay, yeah, that's a good idea. That might work as well.
And
So
since
okay.
since we have
Yeah,
that
it makes sense. Makes sense. It varies over a lot of ratios. Okay, instead of writing it by this, I think it might be easier to do by C. And this is equal to f of x plus fy by C. So look at this and this. Do you see why you must have, this is true for all x, y. Why you must have f of x is f of x plus k for some fixed k.
Yes.
Yeah, it looks like that.
I mean, just take y.
For
is 1. You
x
get
like larger than something, right? Not for all x.
Sure.
Because you can't exactly shift back.
Sure. And yes, okay, yes. That I think is that why you take f of yes, sure. For large things, yes, for large. So we started with fa equals fb. We went to f of x is equal to bx, which is fx is equal to cx. Then we came to this equation, and now we have periodicity. And now, remember, earlier I did x goes, instead of replace x by cx, what will I do now?
Replace x by x.
Sorry?
Nothing.
Replace x by x plus k.
Yes. So instead of this, you would replace x by x plus k. And the point is, again, as before, most of the things should not change. So compare. I let you figure this out, and you get f of xy is f of xy plus yk for all xy. Again, bigger than something, that's okay. So you get f of a equals f of b for all ab. Bigger than some constant. That's fine. You can just take most x bigger than 1 and fix y small, or the other way in the equation, and you'll be done. So, and okay, why do you get this? You just take any AB and you can ensure key A equals xy and B equals this. So you just get constant. So is the proof clear to everyone?
Yeah.
Yeah.
With the non-injective part.
Yes.
Sorry?
What if it's injective?
Yeah, okay. What if it's injective? That's yes. What if it's injective and we also
There
have,
exist equal values because like p of 1 comma y.
yeah, I think I erased it, but you just take yes, you take p of 1 comma y, and you get let's see what you get. You
F
get
of 1 plus f
f
of y equals f of 1 for all y.
yes. You get this, and clearly 1 is not, clearly 1 plus fy is, and clearly 1 plus fy is not 1. So done. So I'll go over the proof once more, and this is called the APMO trick. I'll repeat the trick. So this is generally a trick you do to prove injectivity. Suppose fa equals fb. By something, generally by putting one of the assertions as a and then b and comparing, you get f of ax is f of bx. That is same as saying fx is f of cx for all x, where c is b by a. Then in the given problem, you replace x by cx or y by cy. And as before, you get, with some manipulation, you get f of x is f of x plus k for some k. and this is again true for all x, which is now you get periodicity and you replace x by x plus k or y by y plus k, and this is great. So this is called the APMO trick because it originated from a APMO problem which I'll be giving in the homework for you to try later. But this trick is not really limited to just this. In particular, it's very good to consider, you know, for example, set S to be all x is that fx is, for example, 0, and I don't know, t is all x is that fx is non-zero. And then instead of thinking about equality in f, you can think of the set as, for example, say it's a real f, you can say that x in s implies minus x is in s, or x y in s imply x plus y is in s, and so on. Basically, you can work with the set and get conditions, and this is something you should keep in mind. And maybe not just this, maybe you can have the set as I don't know, set of all r such that f of x is f of rx. I think this is what Cheyenne was trying to do. He was trying to look at the ratios. So you are trying to look at the ratios and you can work with this set. So yes, these are some important ideas. Now I can remember one problem where like you try to consider this set and the set just turns out to be a vector space, and then it's some very old ISL problem where you just look at this set and it turns out to be a vector space, which I find kind of, I don't know, really funny. I don't know what the word to say. Don't worry about vector space, that comes in higher math, but and that is why also I don't know why is it an only problem. But yes, things like this do happen. Vector space is something of a nice structure which is very nicely studied. So yes, is this clear to everyone?
Yes.
Yep.
Okay, so then I think anyways, I'm running out of time. I'll give the problems I intended to give later. Please remember they're not in order. Okay, I'll put the easiest one first so that there exists f. So then you can try. So this is the original problem from where the APMO trick originated. Oh, RMM is Romanian Masters in Mathematics. Oh, if you want, I'll just post the problem. Just give me a minute. You can try this problem. Just give me a second, we'll just post the screenshots. And last. Okay, I think that's it. Any doubts for the class?
How we finished in the last part of the epiometry?
Yes.
How you finished at the last part of the epiometry?
Yes. Okay. So did you realize till here? Till here?
Yeah, here.
Okay. So instead of x, you replace x by x plus k. So let's see what happens. You get f of y, f of x plus k plus fy equals f of x plus k times f of xy plus ky. Sorry for the mess, but this term has remained same. From this term, you can remove this plus k, right? So this term remains same. From this term, you can remove the plus k, so it remains same. So this is the only term that changes. So it must be equal to this term.
Oh, yeah. So we are using y to get all the values. Yeah.
Yes, and then you just like given a and b, you just choose x and y so that you get this is a, this is b, you get f equals f2. Fine.
Yeah, got it.
Yeah. I mean, you can just even fix x, you can fix xy, fix xy to be some constant and vary y. Like take x correspondingly by that. Okay, so I think that's it. If there are no doubts.
Thank you so much. This was a super fun class as promised. And I'm sure everybody else enjoyed as well. Thanks a lot. And
Yeah. And to speak personally, I was doing one of those R2RFEs yesterday, and my AOPS post, the first words are make FEs creative again. So thank you for doing that.
And I don't know if you can hear me because it says my Zoom meeting is not responding, but thank you very
Yeah,
much.
we can hear you. You're
Oh, you
frozen.
can? Oh,
Um,
oh yeah. My Zoom has just hanged.
Can you
Um,
please say the problems? I am after what was the problem just after f of x square plus f of y equals f of x plus f of y square plus 2 f of xy? The r plus 2 r plus problem.
is it the one in homework?
Yeah, homework one. What was it?
Can you tell the which number? Is it like the last number?
It's the one after f of x square plus f of y equals f of x plus.
if possible, I think Malay, if that's okay with you, we'll share these notes with people after.
Yeah, I mean, I'll just put the screenshot on the on Discord. I think that should be fine. Yeah,
Okay, thank you.
yeah, because I can't really do anything here. It's and
Okay.
uh,
Thank